Hi guys. In this video, we are going to be going over rigid transformations. So in your last section, you learned about parent functions, specifically the cube root, the square root, and the logarithmic function. So you guys actually have learned about rigid transformations before in Algebra 1. And so we're actually going to start with what we've done in Algebra 1 to try and, jog your memory and get going before we go into transforming the new functions that we learned about in the last couple videos. So this first video is going to be more review, and then we will get into the more difficult stuff in the next video. So rigid transformations are transformations that do not change the shape of the graph. And what I mean by that is that only the location of the graph is changed. Now you've seen this function before, but in the past, I took something like this and I rotated it, I flipped it around, I moved it left, right, up, down. Notice I'm not doing anything to the function, it's just moving around. So that's what these rigid transformations are going to do. So one way you can use a rigid transformation is a vertical shift. So if you take the function f of x, take the original function, you add k to it. What this is doing is it's representing a translation. You might remember that vocabulary word from geometry. Translation represents a translation up k units. So whatever's happening to the original function, if you're adding something off on the end, you're translating it up that many units. On the flip side, f of x minus k is a translation down k units. So if you were to say a function like x squared, if you had x squared and you added 3 to it, that means that x squared is moving up 3. If I took x squared and I subtracted 3 from it, that would mean that it's moving down 3. So there's a little example there. Now the next one is a horizontal shift. So notice the difference. This is adding k onto the end. This is adding k inside the function. So if I have f of x plus k, that represents a translation and that one is actually going left k units. If I have f of x minus k, that represents a translation right k units. So for your example, we have x squared, and now think back to when we did vertex form. If I had x plus 3 squared, that meant that the vertex went to the left 3 units. So inside acts opposite, and that means left 3. If I had x minus 3 squared, that tells me I'm going right 3. So what I'm about to show you is a strategy that we're going to use in order to make these transformations appear on a graph. So what we generally do, because some of them, once we get more translations, it becomes even more complex. So we look at the function and we think about what is the parent function there. So I'm going to first do this one, absolute value of x minus 2 plus 3. So the parent function of that is going to be the absolute value of x. So I start with the absolute value of x, and I want to actually make a table for that. So I have x and y, and the absolute value of x, the parent function, would look like this: -2, -1, 0, 1, 2, and then 2, 1, 0, 1, 2. So if I graphed that, this is what you would see. All right, so this is my original function. So now what I like to think of is that everything on the inside is happening to the x values. So this here is telling me that my x values need to move right 2. On the end, this is telling me that my y has to go up 3. So what I do is I actually create a table by doing that. So I'm going to add 2 to every x value. And I'm also going to add 3 to every y value to make my new table. So if I add 2 to every x value, this becomes 0, 1, 2, 3, 4. Then I add 3 to every y value. So I have 5, 4, 3, 4, 5. Now I graph those points. So I have 0, 5, 1, 4, 2, 3, 3, 4, and 4, 5. So this here is my new function. So whatever's on the inside, I do the opposite of that to the x values. And whatever's on the outside, I do that to the y values. Graph it. I can see that this function moved right 2 and up 3. So if I'm identifying the vertex here, I see it is 2, 3. And if I'm describing the transformation from the parent function, so that's starting at that absolute value, I'm doing right 2, up 3. All right, so now I'm going to do the same type idea with this function. So again, I have to look for the parent function, x minus 4 squared minus 2. My parent function there is going to be x squared. So if I'm using x squared, I'm going to start with -2, -1, 0, 1, 2. And x squared would give me 4, 1, 0, 1, 4. So I'm going to plot those points. Sketch my curve. And there's my parent function. So now I look at what's actually happening. So x minus 4 on the inside means I need to add 4 to the x's. Minus 2 on the outside means I need to subtract 2 from the y's. So my new table is going to be xy, but this one is going to be -2, and this side is going to be +4. So I'll do the x's first. -2 plus 4 is going to be 2. -1 plus 4 is 3. 0 plus 4 is 4. 1 plus 4 is 5, and 2 plus 4 is 6. Now I'll do my y's. 4 minus 2 is 2. 1 minus 2 is negative 1. 0 minus 2 is negative 2. 1 minus 2 is negative 1, and 4 minus 2 is 2. So now I take that table and I plot the points. So 2, 2, 3, negative 1, 4, negative 2, 5, negative 1, and 6, 2. And there's my new graph. It moved to the right 4 and down 2. My new vertex is 4, negative 2. My transformations are right 4, down 2. So those are my first 2 examples. Go to the next video to get more examples on the more complex problems.